Hi there, this is Professor Eckhouse, and I am talking about multiplying and dividing fractions today. So we're doing simplifying, multiplying, finding reciprocal, and then dividing. As usual, there's a lot of stuff in the book, so be using it, especially as things get harder. All right, so starting with simplified fractions, a fraction is considered simplified if there are no common factors in the numerator and denominator. No common factors. And we talked about a common factor before. Make sure you understand what that means. Which of these are simplified and why is it simplified? Well, 2/3 is simplified because 2 and 3 are prime. There's no common factors in prime numbers. 2 and 6 is not simplified because there is a 2 on top and on the bottom there is a 2 times 3. Okay, so there is a common factor in the top and the bottom. And those, getting ahead of ourselves a little bit, those would cancel out. They would divide out to make a 1. So remember, A over A equals 1. Any number over any number that's the same is 1. Okay, so those can cancel out to basically make 1, right? So that becomes 1/3. That's what we're leading to right now. 15 over 25 is also not simplified because 15 and 25 both have a 5 in them. 15 is 5 times 3, and 25 is 5 times 5. Okay, so we're going to look at simplifying that now. All right, so equivalent fractions property. If A, B, and C are numbers, B and C can't be 0, then A over B equals A times C over B times C, and the other way around, of course. So A times C over B times C equals A over B. Okay, so because C over C is just 1, right? It's just a 1. 1. Do a little fancy 1 right there, okay? And you get left with A over B. All right, so we are going to look at simplifying fractions, and I'm going to show you 2 different methods. There's a one at a time method, which is my preferred method because as you get better at your multiplication facts, common factors will just jump out at you and you'll be able to do it's kind of what I call the shortcut method. So this is really a shortcut, okay? Shortcut. I don't want you to do this until you get good at understanding the prime factors method, okay? So we're going to factor out the biggest factor from the numerator and denominator and then divide out the common factors. And we're just going to keep repeating until there's nothing more that will factor out. The prime factors method is you factor the numerator and denominator all the way to primes. And then you just divide out every single possible number that can divide out like we did up above with the C over C. And then you multiply everything that's remaining and write your answer. Okay, so let's look at a couple of those. All right, 16 over 36, give that a try, see what you can do with it if you want to ahead of me. Otherwise, I'm going to show you just the one at a time method first, and then I'll show you the prime factors method. One at a time, I'm going to look at both of these, and this is where having your multiplication facts down is really going to help. And I think to myself, what's the biggest number I can think of that goes into both of those? If you don't find the biggest, it's okay. It's not the end of the world. You'll just have to do it again. I see a 4 goes into both of those. So I'm going to say 4 times 4 over 4 times 9. Okay, so now I see that 4 and 4 is like A over A, so those are going to divide out. And what I'm left with is 4 over 9. So this simplifies to 4 over 9. Okay, and those are, right, what we talked about last time, these are equivalent fractions. So if I wanted to go back the other way, I would multiply everything by 4, top and bottom, and I would get 16 over 36. So those are equivalent fractions. Equivalent fractions. All right, so let's try another one. Negative 72 over 48. So we've got to throw some negatives in there so you keep thinking about those. So I want you to think of the largest common factor between 72 and 48 that you can think of. And you might not get the largest, and I'm going to show you I did it and I didn't get the largest. It's okay, not the end of the world. So when I see these, I think 8, right? I think 8. They both have an 8 in them. So don't forget to carry your negative along with you, but I've got 8 times 9 over 8 times 6. All right, so now I've got 8 top and bottom, and that is going to divide out. All right, so I am left with negative, don't forget the negative, 9 over 6. Am I done yet? Do you see a common factor with 9 and 6? Definitely. They both have 3 in them. So 9 is 3 times 3, and 6 is 3 times 2. It doesn't matter what order you write it in. You're just going to go look for those common factors, and you're going to factor them out. Okay, so now I am left with negative 3/2. Those are both prime. Primes don't have any common factors, so I'm done. All right, so how would you use a factor tree to find prime factors? All right, so this is what we would do. I'm going to do the 70 first. So I'm going to come over here and say 70. The first thing I thought of was 7 and 10. Okay, so 7 is prime, so I'm going to stop with 7 there. And now 10 is not prime. It is 2 times 5. 2 is prime, 5 is prime. All right, so 70 is going to be, and I'm going to write them in order just because that's what I do. It's just a little easier to keep track of things when you go to start canceling. So 2 times 5 times 7. All right, what about 315? So let's do 315. So 315 is, I know a 5 goes into it because I know my divisibility rules. It ends in a 5. So I'm going to use my calculator and say 315 divided by 5 is 63. Okay, so 63 I know is 7 times 9. 5 was prime. 7 is prime. 9 is not prime. It is 3 times 3, right? So 3 and 3 are prime. All right, so 315, let's write those in order, is 3 times 3 times 5 times 7. Now, I will tell you, when I was doing this, because I made this problem up, when I was doing this, I used a calculator, and I put 3 times 3 times 5 times 7 in my calculator. And I got 315, so I know I did it right. So I encourage you to do that as much as possible. All right, so let's look for common factors, top and bottom. So there's no 2's on the bottom, so I'll go to 5. There is a 5 on the top and a 5 on the bottom. And then there is a 7 on the top and a 7 on the bottom. So those will divide out to make 1's. And I write what I have left, which is 2 over 3 times 3 is 9. 2 ninths, I guess. All right, so you get 2 ninths as an answer here. All right, moving on. If you'd like to work ahead of me, you will learn more, so give it a try. Otherwise, I'm going to show you how to do this. All right, so I've got 8xy and 28y. So these have variables in them. And so for now, because we don't know the exponent rules, I'm going to have you write them all out separately. So first I want to look at the number, and I see 8 and 28. Is there anything that 8 and 28 in terms of factors have in common? So the first thing I think is 4. They both have a 4 in them. So I'm going to write 4 times 2 times x times y. Now you don't have to separate them like that, but I'm going to do it just so I have a little bit more room to write. And on the bottom, 28 factors to 4 times 7. Okay, so that's where your multiplication facts come in handy. I'm going to say that a lot if you haven't figured that out. If you know your multiplication facts, you can look at these numbers and say, I'm going to look for a common factor. I know 8 and 28 both are divisible by 4. Okay, all right, so now on the bottom, I have 4 times 7 times, all I have in terms of variables is y. All right, so let's go look for the things we're going to be able to cancel. I've got a 4 on top and a 4 on the bottom, and I've got a y on top and a y on the bottom. So the 4's are going to divide out and the y's are going to divide out. Color coding really does help, I think, too. All right, so on the top, what do I have left? If it helps you to circle the things you have left so you don't miss them, I encourage you to do that. 2x over what's left on the bottom is a 7, 2x over 7. So that's your final answer. That's a simplified form of that fraction. All right, the next one, just a little bit harder, a little bit more going on. But first I'm going to look at 48 and 64 and think, what is the common factor there? And hopefully you see 8. So we've got 8 times 6 times a times, now b squared means b times b. Again, we don't know we haven't talked about our exponent rules, so I'm not going to use those. I'm just going to write that in expanded form. On the bottom, I have 8 times 8, and then I have a times a times a times b. All right, so now the 8's are top and bottom. I have an a on the top and the bottom. Oh, and I have a b on the top and the bottom. Anything else? Look for it. All right, I don't see anything. So the 8's are going to factor out, the a's are going to factor out, and the b's. And what do I have left? I have a 6 and a b on top. I have an 8 and 2 a's on the bottom. And a times a, remember, is a squared, so be careful. On the top I have 6b and on the bottom I have 8a squared. Am I done? They're both even, which means they're divisible by 2, so I'm not done. Okay, so probably those were both divisible by 16, and that's okay. If you didn't catch that, we could just keep going. All right, 6 is going to be 2 times 3 times b, and on the bottom I have 2 times 4, and I'm not going to factor out the a squared because I know I'm done with those because I already did it. All right, so I've got my 2's are going to factor out, and I am left with 3b on top over 4a squared. I know my variables don't factor out because I've already canceled what I can cancel, and the 3 and the 4, I'm done with those two. Okay, so modeling multiplication of fractions. So here's something really important for you to understand. I guess I'll move this up. Very important. When multiplying fractions, think of for multiplication. So 1/2 times 3/4 is said 1/2 of 3/4. Super important, okay? Really important to think of it that way. And then the models will make sense. And even if you said 1/2 times 50, well, it's 1/2 of 50. So that becomes easier too. So 1/2, so here we've got 3/4, right? So 3/4 is showing in the picture. So how would we take 1/2 of that? So my 3/4 is this portion right here, right? So how would I take 1/2 of that? Well, I would split it in half, right? So 1/2 of 3/4 is just going to be this part down here. All right, so how could we do this without a model? How could we do this without a model? And I should just highlight these right here. So we would recolor the ones that are colored in. Now it is split up into eighths, right? Into eighths. And there are 3 of them because we only took 1/2 of the 3/4. So 3 of the eighths are now colored in. Okay, so 1/2 of 3/4 is 3/8. So how could we do this without a model? Well, we've kind of already been doing it, but we can rewrite this as 1 times 3 over 2 times 4, or 3/8. Okay, so that's multiplication of fractions. So if a, b, c, and d are numbers, and we don't have zeros as b and d on the bottom, of course, we can't do that, no zeros on the bottom, then when we multiply two fractions, we can multiply across the top and multiply across the bottom. All right, so multiply and simplify these. So start with 2/3 times 5/7. Give it a try first if you want. All right, so this becomes 2 times 5 on the top and 3 times 7 on the bottom. So I get 10 over 21. Okay, next one. Does this mean minus or does this mean times? Be careful. So I've got a negative fraction times a negative fraction. So these two negative times a negative, right, become a positive. So negative times a negative equals a positive. So this is going to be a positive answer. So positive answer. I'm going to write it. You don't have to. I just want to make sure it's clear. And we get 3 times 2 on top and 8 times 5 on the bottom. All right. So I want to show you how to reduce this before you multiply. So why make really big numbers and then try to find factors when you've got the factors listed here already? Okay, so what I'm going to do now is I'm going to look for, so that I can simplify, because it asks always we need to simplify. So now I'm going to look for common factors. Well, I've got right here the 2 and the 8 are both even. So I know there's a 2 in both of those. So I'm going to rewrite the top as it is, and I'm going to rewrite the bottom as 2 times 4, or 4 times 2. It doesn't matter the order. Oh, there it is. There's my 2. I brought it out. And now I can divide it out to make 1. Okay, so now we get 3 over, what's on the bottom, 4 times 5, 20. Okay, so 3 times 20, or 3 over 20. 3 over 20. All right, next one, you give this one a try. See what you can do with it. All right, so is our answer going to be positive or negative? Well, we have a negative times a positive, so the answer is negative. All right, so let's look what's going on here. So stop before you get going and think. Just stop and think. Do I see any common factors so that I can factor this out? Of course, you can use prime factorization and prime factor everything. It takes longer, and I find that most of us don't like to do things that take longer, so I'm going to try to focus on this method. But you have to be good at your multiplication. So practice that or do prime factors, whichever one, is going to give you the right answer. So I see a 7 in this one and this one. Those both have a 7. I see a 5 in this one and this one. So I'm going to factor those using, on the top I'm going to look for the 7. So 3 times 7, right? Times, now that's my 21, right? This was 21. And then I've got to factor the 15, and that is 3 times 5. All right, so there's my 15. Right, on the bottom I've got 45, which is 5 times 9. That's my 45. You don't have to do the 21, 15, 45 part. I'm just making sure you're following me. Or the 49 is 7 times 7. There's my 7s. That's the 49 right there. All right, so let's go look for common factors. I have a 5 on the bottom and a 5 on the top. And I have a 7 on the bottom and a 7 on the top. Okay, I'm going to rewrite this just because it's kind of turning into a mess, but hopefully you kind of see there's something else that we're going to be able to cancel. So let's cancel the things that cancel. The 5s are going to cancel out. The 7s are going to cancel out. And on the top, I'm going to get 3 times 3, which is 9, over, oh look, but there's a 9 on the bottom, right there. So as you go, you got to kind of think about what you're doing. I see a 9. So I'm going to leave it factored out because now I can factor the 9s. Lots of ways to think about this. All right, so the 9s factor out. What's left on the top when I cancel everything out? What's left? There's a 1 there. So it's always times 1, right? 9 times 1 or 9. So I have a 1 on top and a 7 on the bottom. So that big thing, oh, and what did I forget? Forgot something. Forgot to carry my negative along, so be really careful. And the negative can go top, bottom, or out front. It doesn't matter. So that big, huge thing just factored down to negative 1/7. All right, so an important tip here, Any integer a can be written as a over 1. Okay, any integer. That means 7 is 7 over 1. 100 is 100 over 1. It doesn't matter what it is. So when you see something like this, it's easy to make mistakes unless you rewrite it. So I would really suggest rewriting this as 1/6 times 36 over 1. All right, so now that we've got that, 36 is 6 times 6, and the bottom is just 6. You don't have to say the times 1 if you don't want to, but you can if you want to so that you can keep track of things. So I'm left with 6 over 1. 6 over 1 is just 6. Another way to think about this is what is 1/6 of 36? 1/6 of 36 means 36 divided by 6. Lots of ways to think of it. And I'm going to keep mentioning all of them to help you be more flexible in the way you think about math. All right, so try that one, see what you can do with it. All right, I've got 7/5 times negative 15a, and I'm going to put that over 1. Okay, so that it's up in the numerator, so it's easier to tell what's going on. And what an ugly 5. I almost made it look like a y. So let me rewrite this. All right, so now let's rewrite it. I'm going to bring this negative out front because I have one negative. It's not going to cancel out, so I'm left with a negative, and I'm just going to have to carry it along with me and not forget about it. So I've got 7 times. Now I see that there is a 15 and a 5 here, and those are going to factor and cancel. So the 15 is 3 times 5, and don't forget your a, so be careful with these. And then I've got a 5 times 1 on the bottom, so I'm just going to do the 5. Now I could write the 5 anywhere I want, so how about if I put it right underneath there, and then I can see that there's the things I'm going to cancel, and I'm going to divide that out. So what am I left with? I'm left with negative 7 times 3 is 21, and then there's an a. So negative 21a. Okay, so that's multiplication and simplifying. All right, so continuing on. Find the reciprocal of a fraction. The reciprocal of a fraction is a fraction that when you multiply them together, you get 1. But the easiest way to think about it is just flip it over, right? Just flip it over. So we go from a over b to b over a. That's a reciprocal. So be careful with signs. The sign stays the same, all right? So a over b times b over a is 1. 3 times 1/3 is 1. They both are positive. But if you start with -3, your reciprocal is also negative, so that when you multiply them together, it's 1, not -1. Okay, so if you take the reciprocal of a negative number, it must also be negative, as I showed there in peak. Okay, they're both negative. All right, so find the reciprocal of each of these and then check. What do I mean by that? I will show you if you don't know what I mean. So try these. All right, so hopefully you gave those a try. So what is the reciprocal of 3/7? Well, it is just 7/3. And what do we mean by check? Well, you take 7/3 times 3/7, and the 7s and the 3s are all going to cancel, and you just get 1. Okay? What is the reciprocal of -1 over 8? Well, that is going to be -8 over 1. So it's got to be the same sign, because watch this. We're going to say -1/8 times -8 over 1. The negatives are going to, right, become positive. And we have, I'll do this in a little longer way. We have 1 times 8 over 8 times 1, or just 8 over 8, which is just 1. All right, next one. We've got -13/3, so the reciprocal is going to be -3/13. Notice I'm not putting an equal sign here. These are not equal. They are reciprocals. They're reciprocals of each other. All right, so check is -13 over 3 times -3 over 13. Make sure you get a positive, and then the 13s cancel and the 3s cancel, and I just get 1. All right, next one, 3. Well, remember 3 is just 3 over 1. So its reciprocal, the reciprocal, is 1 over 3. So 3 over 1 times 1 over 3 is 1. So what is the reciprocal of 1? Well, remember that 1 is just 1 over 1. What's the reciprocal of that? Well, it's 1 over 1, which is 1. So the reciprocal of 1 is 1. So I just checked to show that it is true. It is the only one, the only number that is the reciprocal of itself. All right, last one, 0. I want you to think about this one. Try it before I tell you. So any number is over 1. So what is the reciprocal of that? Well, it's 1 over 0. There is no division by 0. You can't do that. So this is undefined. Undefined. And in the computer, you would put in does not exist. Does not exist. Okay, so the difference between absolute value, reciprocal, and opposite. So these are things we've been learning, and I want to make sure that you understand the difference between all 3 of these things. They are not the same. All right, so the reciprocal of -3/4 is -4/3. That's what we just did. The opposite of -3/4 is 3/4. The opposite means the opposite sign, 3/4. The absolute value always becomes positive, so it is also 3/4. Okay, so try, here, let's talk about this all together now. Opposite means it has the opposite sign. Okay, opposite, it has the opposite sign. Absolute value, it is never negative, it becomes positive. The reciprocal has the same sign, the fraction inverts. Okay, so let's try, I would like you to try this without me. Do the opposite, the absolute value, and the reciprocal of each of these numbers. Okay, so the opposite of -3/8 is 3/8. The opposite of 1/2 is -1/2. The opposite of 9/5 is -9/5. The opposite of 5 is 5. So you just change the sign to the opposite sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. All right, now the absolute value of those is just going to be the positive version of each one. Okay, and the reciprocal is going to be the same sign, and you just invert the fraction. You just flip it over. Same sign, 2 over 1, but you need to write that as 2 because 2 over 1 is not considered simplified. The reciprocal of 9/5 is 5/9. And the reciprocal of -5. So remember, -5 is -5 over 1. So what is the reciprocal of that? That would be -1/5. And you have to keep the sign. So make sure it's negative. All right, let's move on to one more topic, modeling division of fractions. So if we say 12 divided by 3, before we talk about fractions, let's talk about just without fractions. 12 divided by 3, we are saying how many times does 3 go into 12? Right? So if we look at it here, right? We're taking 12 and seeing how many 3's go into it. Well, it goes in 4 times. Another picture is a little bit more interesting down here. Groups of 3. How many groups of 3 make up 12? 4 groups of 3. Okay, so the answer in both cases, right, is 4. How many times does 3 go into 12? So if we say 1/2 divided by 1/6, what does this mean? What does this mean? So we are saying how many times does 1/6 go into 1/2? How many times does 1/6 go into 1/2? There it is. There are 3 of them, right? So there's 3. A whole number, 3. 1/2 divided by 1/6 is 3. All right, so that's not always intuitive, right? Pictures sometimes help, but when we deal with weird fractions, it doesn't always help. So I encourage you to play with the fraction bars in the Math-Gone Polypad. You can use this hyperlink right here to get there. That's a blank one, but these fraction bars right here, it's nice to be able to do it for your own problems and play with it, so you can get a good visual of it. All right, so we're going to model 1/4 divided by 1/8. So what does this mean? How many times does 1/8 go into 1/4? How many 1/8 are in 1/4? All right, so let's model it. We've taken this right here is 1/4, of course, and now we've divided it into eighths. So how many 1/8 are in 1/4? There are 2. So the answer is 2. Okay. So 1/4 divided by 1/8 is 2. All right, another one. Model 2 divided by 1/4. So in other words, how many 1/4 are in 2? How many 1/4 are in 2? So think about it. How would you model that? So you've got 2, and you're going to divide it into 1/4 and see how many there are. Well, as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8. All right, so that's how you model. And there's a Math-Gone Polypad, again, that shows these that I just did. So I think there's a blank one up above, and then I showed you the one that has these here so you can play with them. And you won't mess mine up. It'll open up a new one for you. All right, so now we're just going to use the algorithm and not models. So here's how fraction division works. If we have a over b divided by c over d, then that equals a over b. Notice it has not changed. I'm going to make this a different color. A over b times d over c. So notice that the divide changed to a times, and we flipped the second one. So there's a couple different ways to memorize this. Little rhyme right here. When dividing fractions, don't ask why, just flip the second and multiply. Another one that I have heard is keep, change, flip. Okay, keep the first, change to multiplication, and flip the second. Keep the first, change to multiplication, and flip the second. Okay. So you've always got to reduce after you do the multiplication. So let's start with these. So I'll start you off on this first one. So you've always got to rewrite these. Don't do them without rewriting it, unless you are really, really good at math. Most people couldn't do that. So I would rewrite it myself. So we're going to keep the first, change to multiplication, and then flip this one to its reciprocal. So remember, it stays negative, and we change it to 7/5. All right, so let's rewrite this. So I've got a negative out front because I've only got one negative, and I've got 3 times 7 on top, and 4 times 5 on the bottom. Nothing cancels, so I get negative 21/20. So again, these are not always intuitive and not easy to model. So modeling is nice for simple ones, but for harder ones, you really need to know this algorithm. All right, the next one, 2/3 times, so keep the first one, change to multiplication, flip the second one. All right, so how does this work? 2 times 7 over 3 times x. Well, we would just write that 14 over 3x, and that's the final answer. Nothing cancels out. All right, next one. Why don't you give these two a try? All right, so I see two negatives being divided, so this becomes positive, and the negatives are just going to go away. Okay, so I'm going to rewrite it with the negatives gone. So I've got 3/5. Divide changes to times, and I flip. Now it's not negative anymore. I got rid of both negatives by canceling them out. I changed this to 3/10. So the tendency over here is going to be to look at this and think, oh, look, the 3's cancel, but they don't. They don't. See, now they're both on top. Another is you might see the 5 and the 10 and think they cancel. They do not, because they're both on the bottom. So be careful with these kind of problems. You will see them sometimes just to double check that you're going to remember to flip it over. All right, so we've got 9 on the top. 5 times 10 is 50. I don't see any common factors before I multiplied, so I know there's nothing to reduce, and that's our final answer. All right, next one, we've got 15 over 18. Now I change to multiplication, and I flip the second one. So keep, change, flip. All right, so I do see some common factors here, so I'm going to rewrite this. The top is going to be, I see 18 has a 3 in it, and I see that 15 has a 5 in it. So I'm going to factor those out. So on top, I've got 3 times 5, and then times the other 3. And on the bottom, I've got 3 times 6, that's the 18, times the 5. All right, let's look for common factors that we can factor out, or divide out, or cancel, however you want to think of it. And then I've got the 5 and the 5. All right, so the 3's are going to factor out, the 5's are going to factor out, and I am left with 3 over 6. Am I done? No, I am not. So 3 and 6 both have a 3 in them. So I've got 3 over 2 times 3. And the 3's are going to cancel out. Do I get a 0 on top? No, I get a 1, 1/2. All right, so that big thing, 15/18 divided by 5/3 is just a simple answer, 1/2. How many 5/3 are in 15/18? 1/2 of a 5/3. Okay, I think that is the end. So thank you for watching.